Welcome back to my channel. So this is chemistry question 48 from IMAT past paper 2022. So let's solve this. It says phosphorus is in group 5 of periodic table. What is the shape and bond angle for pH 4 plus positive ion? So we know that this compound that we are given with is polyatomic ion. So the actual name of this polyatomic ion is phosphonium ion. It's phosphonium ion, the actual name for this compound. So before we move any further, to determine the shape and bond angle for this polyatomic ion, we must construct the dot and cross diagram for this phosphonium ion to be able to deduce what structure it could possibly form, the arrangement. Okay, so since we know that phosphorus atom belongs to group 5 in periodic table, it means that phosphorus has 5 electron in its valence electron shell. So valence electron shell means the outermost shell of an atom that has electron in the outermost shell. The further, the most far away from the nucleus that contains proton and neutron. Okay, so it has 5 electron in its valence electron shell, and whereas the hydrogen it basically has only 1 electron. So now we must be able to construct the diagram, the dot and cross diagram for phosphonium ion. So let's do it. So we know that phosphorus atom is going to be the central atom. So I'm gonna draw phosphorus atom here and this outer the valence electron shell. So 5 electrons. So before I draw it any further, I'm going to mention that for phosphorus atom, the electron shape must look like, it will look like X, and for hydrogen, I'm going to draw as dot. Okay. So this is phosphorus atom, 2 electrons here, 1 electron, 2 electron, and then 3 electron. Okay, so this is the outermost shell of phosphorus. So now it's going to form a covalent bonding with the hydrogens. So this is the first hydrogen. It forms covalent bond because there is sharing pair of electrons. And this is second hydrogen. This is the third one. And now we are left with these 2 electrons. So before we move any further, we must know that we use octet rule. So we are going to identify why this positive charge came on this polyatomic ion. So firstly, we're going to count how many valence electron has the phosphorus atom gained, has completed. So we know it has completed 8 electrons. So how? Because basically it has 5 electron in its valence electron shell. These 3 hydrogen contributed 1 electron at least. So 3 of hydrogens together. So 3 plus 5 gives 8 electrons. So we have 8 electrons total in the valence shell. So this means that it has completed its octet rule. But now it also has fourth hydrogen. So how is it going to form the bond with it? It's not going to form like normal covalent bonding because it's not actual hydrogen, but it is a proton. Basically, it has no electron, it's just having proton in its nucleus. So this proton will form a bond with the phosphorus lone pair of electrons. These two cross that you see at the end is these 2 electrons is actually the lone pair of the phosphorus atom. Okay, so To form a bond with this proton, this hydrogen will take the lone pair of electrons from phosphorus atom and form dative covalent bonding. So the rest of other three hydrogens that has formed bond with this phosphorus atom is just normal covalent bonding because they form by sharing of electron with their electron as well. But this hydrogen ion, which is basically proton, forms bonding with this phosphorus atom using the phosphorus atom lone pair. So it doesn't has its own electron because if it has its own electron, it will go against the octet rule because the phosphorus atom already had 8 electrons in its valence shell from these three hydrogens that formed normal covalent bonding. But since it's phosphonium ion it, with the positive charge, it has a proton, a hydrogen with no electron on its own, forms bonding with this phosphorus lone pair of electron to form dative covalent bonding. Alright, so now we have constructed this dot and cross diagram. So let me erase this quickly. Okay, so from this we can deduce that since it has formed 4 bondings to 4 hydrogens, so its molecular geometry is going to be tetrahedral. So it's tetrahedral arrangement because it has central atom that is phosphorus bonded to these 4 hydrogens. So for simplicity, I'm going to draw just this molecular structure. Okay, this is exactly how it looks like for simplicity. So it's a tetrahedral arrangement. So, and we know in tetrahedral arrangements, the bond angle is typically 109.5 degrees. Okay, so this is the bond angle. And let me draw this bracket since it's polyatomic ion. It must have positive charge, overall positive charge. Okay, so it's 109.5 degrees. So the arrangement, mm, the reason why this polyatomic ion arranges into tetrahedral arrangement is because to minimize the repulsive force of the electron bonding. So this makes the polyatomic ion highly stable in this state. So that's why it arranges in this tetrahedral arrangement. So now we know the bond angle is 109.5 and the arrangement is tetrahedral. So we can now look for the options, correct options. So the shape made by atom and phosphonium ion is tetrahedral and the bond angle in the phosphonium ion is 109.5 degrees. Okay, so row 1 is correct. So option A is correct. So this is how we solve this question. Thank you guys for watching my video. I hope you find this video helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.